Hello, calculus students and general seekers of truth. Welcome to the lesson on volumes of solids with a known cross-section, or sometimes referred to as the slicing method. And as usual, before we get too deep into this lesson, it is highly recommended that you watch the videos on volumes of solids and just get a general idea of what we're going to do here, because it's really tough to follow all the details if you don't know basically what we are doing. Okay. Alrighty, so let's get to it. Find the volume of a solid with the base bounded by this function, or this relation, with square cross sections perpendicular to the x-axis. Okay, so what this basically says is that we have a graph, and this is a graph of a circle. Okay, so it's going to look something like this. And it's a circle. This is a center at the origin with a radius of 2. So it's not too difficult to draw this thing, although drawing it perfect might be quite a bit of challenge. Okay. All right, so that's what the base of this thing looks like. And then what we're going to do is for each of these cross sections, which is from one side of the circle to the other, we're going to draw a line here, and then we're going to extend this up, and I'm going to try to draw this as best as I can. Okay, so this is going to be like a slice. This is going to be a square that sticks out of the paper. So it's kind of it's difficult to illustrate this, but it's kind of like saying I'm going to take a Post-it note, because it's a perfect square, and then it's going to stick straight out of this paper, this sheet of paper. And I'm going to do an infinite number of them, and then we're going to try to find the volume of the resulting object. So again, if you don't follow what we're doing visually here, you need to go and look at the prerequisite video so that you truly understand what we're trying to do, because it's really hard to illustrate this when we only have a two-dimensional sheet of paper. Now, the length of each of these squares, okay, so this is a square, and the length of each of these squares is the distance from one side of the circle to the other side of the circle. Okay, so maybe we could best illustrate it this way. This length right here is a half length of the circle. I'm sorry, is a half length of the square. This green line right here is a half length of the square, and this is exactly equal to the y value of this particular circle. So this half length here is equal to 4 minus x squared square root, okay, or the square root of 4 minus x squared. And we want to find the length of the square, so the length of one side, okay, so the side of the squared is equal to 2 times the square root of 4 minus x squared. So keep in mind that the length of the side length of the square varies depending where on the circle it is that you are currently at. Okay. And of course, we are going to add up an infinite number of this, so we're going to take the integral. And notice here that it says it's perpendicular to the x-axis, so it basically is trying to tell us to integrate along the x direction, since they're all sticking out of the paper. So we're going to integrate from -2 to +2. So this here is -2 to +2. The side length here, so I'll label this s squared. Okay, dx, okay, because we're going along the x direction. But of course, s is equal to this expression. So we have 4 times 4 minus x squared dx. And for these types of problems, it is simple enough that we should be able to integrate this without a calculator. So this is the integral from -2 to 2 of 16 minus 4x squared dx, which is 8x squared minus 4/3 x to the third, evaluated between -2 and positive 2. So work out the arithmetic, and we get that final answer is equal to 128 over 3. And again, this is the volume. Okay. So many of these problems are the same as what we had before. We started here with a square. Okay. And in the next example, we will deal with a question that has an equilateral triangle cross-section perpendicular to the x-axis, and maybe we'll deal with some that is perpendicular to the y-axis, which just means we have to integrate along the y direction. So I'll stop this video here, start another one where we deal with some of the other examples. Thank you for watching. Be sure to watch the next one.